All right, guys, let's get started on 1.2, adding integers. So, of course, adding addition, which is nice. We'll only be looking at just this individual operation with integers, so mainly positives and negatives. So these are just parts of an addition problem. You got the two add-ins, which are the numbers being added in the sum. I don't use this vocabulary very much, but I don't know, some people are interested in it. So there's different ways to add integers, and one of these is with the number line. Okay, now, again, even on the homework, I don't remember seeing that they require you to add with a number line. I think it does on it, like they have some examples with number lines in Canvas, but again, if we were to have a test, it would just say add the numbers or operate on the numbers rather than add with the number line. Okay, so if you're like, I really don't like the number line method, you don't have to use it, but I'm going to show it to you anyways because well, it's part of the curriculum here. So when we add numbers, let's look at this first set here, the -2 plus -3. And when we add with negatives, we usually put the negative in parentheses. Otherwise, like if we were to write this out as -2 plus -3, if I wrote that -3 without parentheses, it may just look a little confusing. Like, am I adding here? Am I subtracting? I don't know really what the crap I'm doing. So we try to avoid that, okay? All right, so in this problem, we're going to use the number line to add, and again, it's not required that you use it. But the first number, or what do they call it, an add-end, this is where it tells us to start. All right, now, people use the number line differently. So some people would say you always start with 0. I don't start at 0. I start with the number farthest to the left in the addition problem, which in this case is -2. So I identify -2 on the number line, which is right here. Now, addition usually tells us to go on the number line to the right. Okay, but this is a -3 right here, so it's the opposite of the right. So we talked about how negatives are opposites. It's the opposite of the right. Well, what is the opposite of the right? Overall, that would be to the left. Well, how far to the left? 3 spaces. So I'm going to go to the left 3 from this -2. 1, 2, 3, and I end at this -5. And that is my final answer for this problem, -5. So in this next problem, I'm just going to do it the same way. Again, the first number, that's where I'm going to start. So I'm going to start, there we go. Add 5 right there. Now, another way to show this, and I'm getting a little bit ahead of myself on this one, is if you see plus a negative, you can just change that to a big minus sign. It's the same thing as 5 minus 8. So if you wanted to rewrite this as 5 minus 8, you could. Okay, now we still start at 5, but the minus tells us to go to the left immediately. So by moving this to the left, how far to the left? 8 spaces from 5. So where I got that purple mark, I'm going to go to the left 8. 1, 2, 3, 4, 5, 6, 7, 8, and I end at -3. So the final evaluation for this one, bam, -3. So that is how you use number lines to add with integers. Now, we even kind of showed with the minus, I suppose, with the 5 minus 8. But adding negatives is the same thing as subtracting. So if you feel more comfortable showing it as subtraction, feel free to do so. Just keep in mind when the numbers get real big, right? Sometimes this becomes a little impractical, just because when you have lots of or big numbers, it's kind of hard to say, well, I'm going to go by ones, this number of spaces or a lot of spaces, okay? So there's other methods for doing it, and we'll see those, but Again, hopefully this was kind of helpful for us to know why things happen the way they do with adding integers. So another way to do it is with counters. Again, this, I don't know, man, it's hit and miss. It's like some people like the number line, some people like number lines and counters, some people don't like counters. I just never know. So I'm kind of feel like I'm rolling the dice on all this stuff. But what we're going to do is we're going to look at these as counters, right? So I'm going to take red ones and we'll say black ones. I know this doesn't make sense yet, but I'm going to say that a red dot, maybe I should use red, is a positive. No, I think the reds are usually negatives, actually, so we'll keep it that way. Red is negative. Specifically, a -1. Now, where number lines aren't necessarily always scalable, these ones are. Not that we should have to. And positives are the black ones. This would be a positive, will represent a +1. Uh-oh. Spelling's not my strong suit. Sorry about that, you guys. All right, so if a black dot is a +1 and a negative is a red dot, -1, then if I were to demonstrate this problem, -4 plus 6, I would start with the -4, right? Which is 4 -1s. 1, 2, 3, 4. So that's 4 -1s, which has a total value of -4. And then it's plus 6. And yes, we could show that as plus +6. Not that we should have to, but we can. Which means that I'm going to have 6 of these positive counters. So there's 1, 2, 3, 4, 5, 6. Okay. Now, as I combine these, I guess more specifically, as I combine a set of a red one and a black one, so that's a -1 and a +1. Those are exact opposites, right? So it's like saying I got a +1 and a -1. Let's add these together. All right, well, when you add opposites together like this, 1 and -1, you get 0. So in other words, 0 has no value, and I could just say, oh, I'm just going to erase that garbage. Okay, I'm not going to. But, and I'm only keeping it to show the 0 pair there, okay? This is called a 0 pair because their overall value is 0. How many 0 pairs can I create from these counters? Well, I just did one. There's another one. There's another one. There's another. There's 4 zeros in this one. And again, these have no value, so I can really just ignore them. The next thing I would consider is there any more 0 pairs I can make? In this case, there is not. I'm just left with these 2 black counters, which represent +1, right? So what's the total value here? 2. And again, I don't know if you guys like that or not, but I do like the counter examples. I like them more than the number lines, but you guys can decide. Now, I did mention 0 pairs in this example. That's going to come back. We're going to look at 0 pairs in more detail in a later section. So keep that in mind. 0 pairs is where you combine opposites together. And it'll be especially important when we start solving equations. Now, of course, there's just adding integers with the same sign like we have here. 4 plus 7. That's an old-fashioned problem. So just 4 plus 7. You can add it vertically like this one by place values. And in this case, we just got ones, right? So 4 plus 7, bam, is 11. So the answer to this one is 11. That's pretty good. Now, one thing we should consider on this next problem, though, it's a -6 plus -5. And -6 plus -5, I guess my first question would be, is the answer going to be a positive or negative? Now, when we look at problems like this one with negatives being added together, if it's only negatives, what's going to happen is the numbers are going to get, they're going to stay negative. They're just going to become more and more negative. So from that, I can know that my answer is negative. And since it's becoming more negative, I'm just going to add the negatives together. 6 plus 5, which is in this case 11. But again, I keep the negative as part of the answer on that one. So when you add negatives to negatives, you're just creating something that's even more negative, right? It's like saying if you had $6 in debt and you added another $5 in debt, does that mean we're taking away debt or we're putting on more debt? Well, of course, we're putting on more debt in this case, which is why we get a bigger negative answer. Now, that last two examples, that was adding integers with the same sign, right? Like we had the two positives added together, we just add the numbers. If it's two negatives together, add the two negatives, keep the sign, okay? So keep the sign, add the numbers. But when they're opposite signs, like we see in this example, these two examples, there's a couple things to consider when we solve these problems, okay? And the first thing we want to look at is there more positives or negatives? And that will determine the sign, okay? So in this particular problem, with negative 2 plus 11, 11 is positive, and there's more positives than negatives. So I can put my sign out here right now. Not that I need it, because it's positive. But I can know that my answer is positive. From here, what we're going to do is subtract the two values. The big one, take away the small one. And it doesn't really matter which order these are in. Like it could have been written as 11 plus negative 2 like this. The answer would have been the same. So 11 minus 2, bam, it's 9. So our final answer there, positive 9. Again, if you don't show the positive sign, that's fine. In fact, on the homework, we would recommend not doing it because it would interpret it as a plus sign instead. All right. Now, again, this is with opposite signs. So in this next example, again, the signs are opposite. I got a positive, and then we got the negative. So again, we need to consider, are there more positives or negatives? Well, 16 is positive, 7 is negative. 16 is bigger than 7. So I know my answer is going to be positive. And from here, we'll do the subtraction. Big number minus a small one. 16 minus 7, which is, oh, it's 9 again. I don't know if that happened on purpose or not, but that's what it is. Now, in both of these examples, we had more positives than negatives. If by chance there were more negatives than positives, then our answer would be a negative. And then you would still take the big number and subtract the small number, no matter which order it's in. Now, if we go back, just with the counter examples, is in this, let's look at the first one, negative 2 plus 11, right? The reason why we subtract is because these two negatives are canceling out as 0 pairs 2 of the positives, which is why we end up subtracting in this case. So just as general guidelines, when adding opposites or adding with opposites, and you're going to keep the sign of the bigger number and then subtract the small number from the big number. So it's big number minus small number. Adding with the same signs, you just keep the sign, add the numbers. So even if they're negatives, you're just going to keep the sign negative, add the two values together. Following the order of operations, I don't remember seeing one like that, but again, you're just working from left to right, combining terms with the same sign. Yeah, these are all just methods for doing it. We looked at using a number line and counters. This fourth one here, combining terms with the same sign and then combining the terms. That's not a very common way to do it. So I don't really show it that way. So in this case, it says add the integers using the order of operations. All right. Well, order of operations says that we do parentheses first. There's no operations in the parentheses, so we're good. There's no exponents. In fact, there's no multiplication or division from left to right. There's only addition because this section is called adding integers. So, moving from left to right, I would just look at the 43 plus the negative 54. Now, these have opposite signs, right? And 54 is the negative, which is more negative than the 43 positive. So I know my answer is negative. Then I take the big number, 54, and subtract the small number, 43, which appears to be 11. So 43 plus negative 54 is negative 11. Again, rewriting my new expression, negative 11 plus 91. Now I'm adding a positive value, which is more positive than the negative. So when I combine these, I'm going to get a positive answer. And I take the big number, 91, subtract the small number, minus 11, which is 80. So my final answer, positive 80. I don't really need to include the positive in the answer because when we don't show the sign, we already know that the answer is a positive. All right, we'll add these using the order of operations. So 51 plus, in brackets, 6 plus negative 10, brackets, plus negative 15. You know what? You guys try this one. We'll give you 30 seconds, okay? 30 seconds. Go ahead and try this one. All right, here we go. So in this problem, I got to start with this set of bracket parentheses, right? And we'll just evaluate the inside of that, which is 6 plus negative 10. Now again, in this addition, I have more negatives. They're opposite signs. I have more negatives than positives. So I know my answer is negative. I'm going to take the big number, which is 10, and subtract the small number, which is 6, and I get 4. So I end up with negative 4 in that set of parentheses. Let's rewrite the problem. All right. Now again, just by the order of operations, we'll just review them real quick. There's no exponents, there's no multiplication or division, only addition, and we're moving from left to right. So 51 plus negative 4. In this case, I have more negatives than positives, so I know my answer is positive there. Take the big number and subtract the small one, which is 4. 51 minus 4. 1 minus 4, I need to borrow. Okay, not everyone needs to do this part, but 11 minus 4 is going to be 7. 4 is just 4, so 47. So I get 47 out of that, and the rest of the problem, right, plus negative 15. And combining these, 47 plus negative 15, I got more positives than negatives. So I take the big number, 47, and subtract the 15. 7 minus 5 is 2. 4 minus 1 is 3. Then we get 32. All right, now again, this method is not as commonly used when adding integers, but it is definitely a possibility to do, okay? Now, in the end, we should end up with addition on this, okay? Now, the commutative property allows us to move values. Now, when we use it, we're going to look specifically at values with the same sign, particularly negatives and positives, of course. So I'm looking at the negative 2 and also the negative 10, right? And I moved those together so I can add them. Negative 2 plus negative 10, so we know it's going to be negative, and then 2 plus 10 is 12. So I get a negative 12 from the negatives. Then we look at the positives. Now, you could have done the positives and the negatives. It doesn't really matter. I just saw the negative 2 first, farthest to the left. So I'm going to focus on positives now. I got 5, 18, and 4. So I can add those together. 5 plus 18 plus 4. Now, you could have done it one at a time, right? Which would have been fine. But I can do them all together. In the ones place, I got 5 plus 8, which is 13, plus 4, which is 17. Carry the 1. 1 plus 1 is 2. So I end up with 27 there. Negative 12 plus 27. When I combine these, I have more positives than negatives, so my answer is positive. And then we subtract the 2. The big one, 27, minus the small one, 12, which is 15. So the final answer here, 15. Now again, this is a lot of different methods. You could have used counters if you wanted to. 18 is a lot of counters to put on the page. You could have used just the straight order of operations by moving from left to right. Again, it's really up to you guys, okay? All right, next we need to be able to do addition and word problems. They sometimes just call these applications of addition. So here's some keywords we're kind of looking for, like, of course, added to. If you see add, generally speaking, it generally means addition, of course. But sometimes it'll be something like combined, maybe it's a deposit increasing. Sometimes it's something that goes up, or a sum. Of course, a sum is the answer to an addition problem. Or maybe it's something that rises, okay? So for a problem like this one, you are in a submarine and are at a depth of 42 feet below sea level. Your depth changes to 60 feet below sea level. Did you go up or down? This one is just asking, did you go up or down, right? So you're starting at 42 feet below sea level. Then your depth changes to 60 feet below sea level. Now this is one of those up and down number lines. I like up and down number lines because they remind me of the old thermometers that had mercury in them. You know, then you used to break them in half and then try to poke your friends with them because they had mercury in them. Teachers didn't like that though. We got in a lot of trouble. But in any case, we got 0 right there. Negative values are down, so I got a negative 42 right there. 60 depth is even farther down. That shows a negative 60, So if we start at 42 and we end up at negative 60, we can see that we went down. And that's the only question it asked right there. I mean, it could ask how far we went down, but it's not. It's just saying, did you go up or down? Okay, down. One of the reasons it's not asking how far we went down is because that ends up being a subtraction problem. This should only be for addition. All right, this one's a good one. If you are in a submarine and are at a depth of 44 feet below sea level and rise 30 feet, what depth are you at? Okay. So again, it's not required that you use a number line. I'm just going to do it because, I don't know, I think it looks good too. So it says you're at a depth of 44 feet below sea level. Okay, so I'm going to put 44 down here. It would show as negative 44 because it's below sea level. But then it says that you rise 30 feet. So I'm going to go up 30 feet, right? Now, again, you could count 30 up in here and then figure out what you get. Or you could write the problem as negative 40. And then you went up, which is an addition problem. I put 40. I meant 44 there. There we go. So we got negative 44 plus 30. We are adding opposite signs. And there's more negatives than positives. So I know my answer is negative. Then we just take the big number and subtract the small one. 44 minus 30, 14. So your final depth, if you started from 44 feet and rose 30 feet, you would end up here at negative 14 feet. Or, like you could, I would be okay like if this was like a written problem, if you guys wrote negative 14 feet. I suppose on the homework, though, it would say something like, you end at 14 feet below sea level. Oh, that didn't come out very big. Oh, but it's there. So I assume that's kind of one of those fill-in-the-blank problems for the homework. All right, John's bank account was overdrawn. The status of his account was negative $317. Uh-oh, John. He did not realize the problem and wrote another check for $16. All right, I know some of you guys are thinking, who the crap writes checks anymore? People in math problems do, okay? The bank charged him a $44 fee for being overdrawn. What was the new status of John's account at this point? So in other words, how much money does he have in his account, or what's the net worth of his account at this point? So looking at this problem, it says that he started out with overdrawn by $317. So that's a negative $317. Now he's writing another check for $16. Now that money would come out of his account, and there's a couple ways to show money coming out, and some of you guys are thinking subtraction. I'm going to keep this in terms of addition just because this section is addition of integers. So it'd be like taking negative 317 and adding another negative 16, because he's writing the check, that money's coming out of his account. Yeah, I guess we kind of make that assumption that you guys at least know how checks work, even if you don't use them. Some of us are old enough to remember when they were very popular, but some of you guys may be old enough not to, so hopefully that's helpful. So the bank, for writing that check, bam, they're going to charge him $44, which is going to come out of his account, which doesn't have any money, but they're going to charge him. So we're going to add that negative 44 right there. Now this one's pretty nice. So this is the math expression that comes out from this problem. Now again, if you wrote it as subtraction because you're like, man, I really like subtraction in this problem, okay, feel free to do it. We're going to go over subtracting integers in the next section as well. Now in this problem, all three of these are negatives. And we're adding these together, so I just know whatever number I get is just going to be really, or it's going to be bigger negative. Which means I can take the three values, 317, 16, and 44, and simply add these together. So 7 plus 6 is 13, plus 4 is 17. Carry the 1 into the tens place. 1 plus 1 plus 4 in the tens place value, bam, another 7. And the 3 we're just going to drop. So John, after writing that check and having his account already overdrawn, the status of his account would be a negative $377. Or in other words, he owes the bank $377.